Okay, so we are talking about calculus at this point, and so far what we've done in this course is we've gone through the first principles. The whole idea of first principles is to talk about how we go from a secant, right, which is a line basically connecting through 2 points in a function, to a tangent, which means the line basically goes through 1 point. And the way we did that was we set h to 0, right? So h is the horizontal distance between any 2 points on a plot, on a function. And so if you make h approach a really small value, what happens is the 2 points become a tangent. So I could show you that graphically here. So let's say we got 2 points. You draw a line through them, and you've got basically the secant of the function at those 2 points. But let's say we take this point right here and we progressively bring it closer and closer and closer to the original point. What ends up happening is the secant approaches a tangent for the function. And so the slope of this thing is called the derivative. Okay, so that is basically where the derivative comes from. Now, we showed how to do that, how to find the derivative or differentiate by doing basically first principles. So I had to evaluate a limit. Now, question is, are there shortcuts to determining the derivative, right? Are there some rules that we could apply? Are there patterns for these derivatives where we could apply the patterns and all of a sudden get the derivative in one small step instead of doing the whole first principles action? The answer is yes. Okay, so what we're going to start off with are the rules for power functions, x to the n. Okay, so if I give you a function x to the n, the derivative is right here. So this is the derivative of x to the n. Now, so how do you evaluate the derivative? What's the pattern? What do I do? Well, I take the exponent, which is n, and I bring it down, and I multiply it by whatever number is in front. I then take the exponent and I subtract 1 off. That's it. That's how I determine the derivative. Same can be said if you have a vertical stretch, factor a. Okay, so then the derivative would just be n times a, x to the n minus 1. It's the same process. I bring the exponent down and I subtract the exponent by 1. Now this right here in front is a product. So that is a product. Okay, so here we go. Let's determine the slope of this function when x equals 9 over 5. This just means derivative at x equals 9/5. That's all it means. So let's evaluate. So dy dx is going to be, let's see, let's take the exponent. What's the exponent here? 4. Drop it down and multiply by 2/3. Then take the exponent and subtract 1. We multiply the coefficients in front to get 8 over 3, and then x cubed. That's the derivative. And this is basically, this is the slope, the slope of tangent at any x. So to get the value they want, you just go m equals, and you plug in 9/5 cubed. Okay, and that's what you get. So then if you were to evaluate that fraction, you get a ratio. 729 times 8, so you get 5832, and then 125 times 3 on the bottom, 375. Okay, that is the slope x equals 9/5. So all you're doing is taking the derivative and plugging in the x value. And that is the power rule. It's one small step, one giant leap for mathkind. Okay? So here's the question. If I've got a power rule and the power function I start with is very small and simple, what if I have a sum of small power functions? In other words, a polynomial function. What does the derivative rule look like there? It's the same rule. It's the same power rule. You just apply it term by term. So in each of these terms, what I would do is drop the exponent down to multiply by the coefficient and subtract the exponent by 1. So I would get ax to the n minus 1 times n plus bmx to the m minus 1 and keep going. That's it. So let's try evaluating the derivative of p of x. Now p of x, its derivative will just be p prime of x. So this just means p prime of x. Okay, that's just the derivative. Okay, derivative. It's the same thing as dy dx. So here we go. P prime of x. Bring the 3 down and multiply by 0.2, you get 0.6. Subtract the exponent by 1, and you get 2. Bring this exponent 2 down, multiply by 0.7, you get 1.4. And you get x to the 1, or just x. Now, this exponent right here is a 1. So if I bring it down and multiply by 3.5, I get still 3.5. And then if I subtract 1 by 1, I get nothing. So I get a constant, negative 3.5. Now, the derivative of a constant, derivative is always going to be 0. Okay, so it's like I'm adding nothing at the end of it. And so in the end, this is going to be my derivative function. Now, it's not saying in this question to determine the slope when x equals a certain value. Instead, it's saying determine the points, and by points it means coordinates x, y, okay, where the tangent has a slope of 4.5. So whenever you see this terminology, what it actually means is determine the values of x where derivative is 4.5. So what we're going to do is we're going to set this thing to 4.5. Now, we're going to have to solve this equation for x. So this is a quadratic. So you have to solve this quadratic equation for x. That's exactly what we're going to do here. So we're going to bring this over, this 4.5 over to the other side. You get 0.6x squared plus 1.4x minus 8. Now, these are decimals, so we've got two options here. Either we can try to factor by first probably multiplying by a factor, a multiplicative factor to simplify these numbers, or you can do quadratic formula. What I'm going to try to do here is I'm going to try to multiply both sides by 5 and factor. Okay? So here we go. So what I have to do is I have to multiply everything inside this bracket by 5. What you'll end up getting is 3x squared plus 7x minus 40 equals to 0. This is much nicer. Okay, I can actually factor this. So what I end up getting is 3x let's see, minus 8x plus 5. Let me double check that. Plus 15, yep, that's correct. So if I set each bracket to 0, I get x equals to 8/3 and x equals to -5. There you go. Now it does say points, right? So I do need a y-coordinate. So all I would do now is evaluate p of 8/3, which equals to something, and then p of -5, which equals to something, and then therefore the points are 8/3 and p of 8/3 and -5 and p of -5. There you go. So these are the 2 points to solve the question of where the slope is 4.5. Basically, that's the idea. So that's the power rule. Next, we're going to apply the power rule, but to rational functions. And we're going to apply the power rule to radical functions. So it's the same process, same rule, just a few more steps, just a few more. All right, see ya.